My name is Berkan Fidan. I am from OYAK Cement Group. Today I will talk about our digitalization and AI in manufacturing project. I will explain our project and what we did by the help of Pi. I want to start with a quick introduction about our head company. It's CIMPOR Global Holdings. CIMPOR Global Holdings is a group of companies established by OYAK and Taiwan Cement Company and operates in the fields of cement, concrete, kraft paper, and bag. CIMPOR Global Holdings operates in several regions of the world. Netherlands, the headquarters of CIMPOR Global Holdings, and the operations in Turkey, Portugal, Romania, Ivory Coast, and Cape Verde. Incorporates the OYAK Cement, CIMPOR Portugal, and Cape Verde, and CIMPOR Côte d'Ivoire brands. When we look on our cement operations, our structure in Turkey, it's Turkey's largest cement and concrete brand, OYAK Cement. 22.5 million tons of cement production and more than 12 million tons of clinker production in a year. There's a capacity of that group. And the second one is CIMPOR Portugal and Cape Verde. The leader of the cement industry in Portugal and Cape Verde with a capacity of 5.5 million tons of cement production and 8.4 million tons of clinker production. And we have also facilities in West Africa. Actual one is in CIMPOR Côte d'Ivoire, world's first greenfield calcined clay integrated cement plant. And the upcoming one will be commissioned at the beginning of next year in Cameroon. Now, I briefly to explain our digital transformation journey, and we named the project as OYAK Cement 4.0. And the project is the main aim and its solution and its benefits. I can summarize like that. Our main focus, it's online visualization of cement plants in 3 different continents. At nearly 16 different cement facilities to collect their data and to create an AI-supported industrial operations. And the main use cases, what we did are in-process predictions to improve our efficiency, productivity, and our quality of the main products. And we aim to catch high reliability with predictive and prescriptive maintenance methodologies. Additionally, for the sustainability side, we focused on tracking CO2 emissions and optimizing our NOx emissions. And these targets are based on with some solutions by the help of Pi. We developed our main architecture by AF structure with some standardized and unique formats. Then we just established a drill-down visualization format with the help of Pi Vision, and we classified text and calculated artificial data are filtered, validated, and transferred to simultaneous AI engine and platforms by the help of Pi integrator for businesses. And also AI-supported predictions are collected again in the Pi system and monitored and also analyzed by the functions of Pi Vision. And by the help of that one, we could also see the actual value in online, and also we can check past, and we could also show the future data. What we gained, just briefly to explain, the improved capacities, less energy consumptions, and higher overall equipment efficiency. And accuracy and efficiency on pyroprocessing and grinding states in cement production, and anomaly detections on equipments before failures, and predicting the potential failures before they happen. And predicting upcoming NOx emissions and managing and optimizing the values to reduce the effect of NOx and its emissions. And also CO2 emission levels actually can be calculated and followed and tracked by the help of Pi Vision and by the effectiveness of Pi asset frameworks calculation options. When we look on more detailed on our motivation on digitalization in cement industry, the location and regional divisions of our plants and spread three different continents. And we have many data available to collect from a cement plant. Just the calculation base, it's nearly 800 billion individual records we could catch by the help of Pi. And we can also unique quality evaluation principles due to our product characteristics. And we could optimize and manage our quality and production plan by the help of future predictions by the use of data. And also continuous processes and relational efficiency effects. And we are also focused on, we also just focused in our, one of the main motivation reason is the energy consumption in cement industry, because cement is an energy intensive manufacturing process. And we need to improve, we have still some advantages. If we could improve and increase our efficiency, we could gain both efficiency and also money by the help of that one. And also our aim is to decrease our maintenance costs, and we could do it by the help of accurate preventive actions, and we could catch high reliability. And also lastly, but it's one of the most important one, our motivation is to decrease our CO2 effects and emissions, and to support our sustainability programs. What are the challenges? It's just of this project. It's just in our project adaptation progress. It's the well-organized and globally connected monitoring structure is a hard issue to just because different brand names of sources, different types of sources are available. We need to collect all the data, combine it. It's one of the hardest points. And also standardization of formations and digital asset structure is one of the hardest parts. Variety of data sources, connections, and attributes is also another challenging point. And also timestamp data is critical part. They need to be matched with each other because there are also some additional sources like quality and maintenance data. And also dynamic editing options is required because there need to be some fine-tunes, additional calculations without losing original data. It's also critical for us for this project. And also AI compatibility and just integration with some other machine learning modeling options is also a critical option to get them online basis, because while on stream watching, you need to also see that on stream predictions and upcoming results for future. It's also critical. And also notifications. It's people need to be warned, notified according to operational conditions. And we solved that issues just with the help of the main data structure, data foundation. It's by the help of Pi Explorer and PiIF, we just originally designed and just several artificial texts and some complicated calculations just maintained. And also standardized formation and hierarchical structure of AF helped us to form that structure. And the visualization part. It's one of the best and strongest part for us because we just designed that part by the help of our team with a unique design and some drill down formations from country-based, plant-based down to a signal on a single drive or on a fan or any equipment in the plant. And also we could do some ERP and web-based data interactions. We could collect data from web, and we could take some sales figures and show. Also, we could get some web-sourced data, and we used and visualized it and combined that data while analyzing our plant operations. And then the one of the important part is also not only monitoring, also the real challenge is to touch directly to the operations. And we're just doing by the help of predictive maintenance with AI assistance and monitoring with Pi Vision. We just send data from Pi system to our AI platform. get the predictions and feedback to the Pi, and we could watch it and we could follow it with the trends and with the actual data, and we could also archive it, that predicted values, on the Pi. And it helps us to just monitor it and also to notify the people and the plant operators and also all the related technical teams. One another thing is for in-process predictions. We just predicting some figures, some values, and some details. Just give an example. It's in cement industry. There is manual sampling is operated. Just some samples taken from the field, taken into laboratory, and some tests applied over it. And it takes some time. And some critical parameters like free lime and cement kiln and fineness calculations of a cement grinding process can be evaluated at least 1 hour, sometimes it's 2 hour periods. But by the help of that collected data, we analyzed it on AI structure and feedback into the system, and we could predict with more than 90%, 95% accuracy. We could predict free lime and blane finesses nearly each minute, and we could feed it into the Pi directly. By the help of that one, not an hourly based points, we have nearly 60 points in an hour, and we have 60 times higher data available. By the help of that one, we could manage the process, we could optimize our efficiency with high amount of operational parameter. As you could see also just a trend in here, it's just an version, it's an example of free lime prediction. The orange line, it's an actual lab analysis and the predicted values. As you could see that all that deviations could not be catched due to that hourly or 2 hourly period analysis. But by the help of that one, we could manage it and we could optimize our process according to that fluctuations. One another thing, it's just, as I said, it's blane fineness prediction in cement mills. Again, samples taken and the fineness rates measured in lab analysis, but we could predict in each minute just the blane fineness and also C residues. And with accurate predictions, we could manage cement grinding operations, and we prevent finer grinding or coarser grinding, and we prevent quality fluctuations, and also we gain energy by the help of that optimization. And it's again an example of that operation. It's, as you could see, only 5 or 6 actual data in that diagram, but more than 300, 400 points predicted. And one another example, as you could see that, it's again fineness prediction. And again, a fineness prediction. As you could see that the actual really matches with the predicted value, and we could optimize our process by the help of them by using some advanced process control tools to just directly feed it and to manage it. And additionally, both AI-assisted applications are directly affected CO2 emissions and carbon footprint of products because of less energy consumption, more productive approach, and also decrease on heat energy and electric energy consumptions. And also by increasing the quality, we decrease our clean air usage and parallelly decrease our CO2 emissions per ton of our product. The other step is about emission controlling. We could watch our emissions of our plants, one of the critical issues for us. We could calculate actually, instantly about CO2 emissions, what we are producing now. And we could see also daily, monthly, and yearly basis to just catch the values and to check what's happening. And also we are predicting NOx. NOx values is also a critical issue because there are some limits and we need to control that figure. But it's not easy due to some process-related issues. But we could manage NOx values by the help of that additional data, AI predictions, and also we add visual screenshots from our flame monitoring cameras and combine that visuals with the numerical data, and we could predict NOx for upcoming 30 seconds. By the help of that one, we could decrease and we could control the NOx in an optimum level. As you could see, it's just in here, the actual one and the predicted figures for NOx. And when we look on the annual effect of OYAK Cement 4.0 in CIMPOR Global Holding, there are many, it's a combined efficiency, combined advantage issue because many investments and process improvements done. But when we look on the gains, what we did, at least 1% of heat efficiency could be gained by the help of that AI. That means 17,500 tons of coal consumption. And we just save that amount of coal per year. And we saw that we could gain at least 1% of electrical energy by the help of explained optimizations and the other figures. That means also 12,600 megawatts hours per year less energy consumption. It's also an advantage of the optimization by the help of data collection and AI. On the other side, we could burn alternative fuels like waste, municipal solid waste, waste tires, and some hazardous waste to replace our fossil fuels. But the problem is that there need to be some process adaptations. At that point, by the help of optimization, we could burn much more TSR, and at least 2% increase could be catched by the help of data analyzing by that operations. And that means 30,000 tons of less fossil fuel consumption per year. And also 1% of clinker incorporation rate can be decreased because our main component is clinker, and that's the main reason of the cost and also CO2 emissions inside the cement. By optimizing the quality parameters, by the optimization of quality, we could decrease our clinker consumptions. And at least 1% of this effect may happen with that operational efficiency of AI and the data digitalization part. And that means nearly 110,000 tons of clinker saving per year. And also maintenance cost. As I said, we have some applications, we have some predictive approach on three-dimensional vibration controls to manage, to prevent failures before it happens, to warn people when any anomaly detected, and also to predict future failures before they happen. It helps a reduction on maintenance cost. And it's nearly just €1 million per year saving. Consolidation of all those efficiency improvements have some positive, as you could see, that economical effects. But additionally, there is a huge effect on sustainability side. Nearly 140,000 tons of CO2 reduction could be done by the help of that operations, as explained as above. And that's an equivalent amount of CO2 reduction. It's equals to 6.5 million trees 1 year absorption, CO2 absorption rate. Still, additional use cases and potentials are available, and our project is going on with next phases. We are just in the beginning of digitalized and AI-assisted industrial ops transformation. And when just to summarize and to give up a quote in here, I can say that processing operational data with AI has a booster effect on industrial performance, but there must be a strong, adaptive, compatible, and manageable data infrastructure. Otherwise, it will only be a nice story with some virtual results, and the storytellers may change, but it's still only a black hole for efforts, investments, and time. Thanks for your listening. You can just contact me from my mail address in here, and thanks for that invitation to AVEVA and PI for that participation.